Hey everybody, we are here. You should be able to hear and see me right now. Hey Dylan, can you hear and see me, Dylan? It's funny, like the one time I don't do a check, I think because I'm in the new studio, makeshift studio, I'm always afraid people can't hear and see me. Like I'll just be broadcasting and I'll be like, okay, let's do a few more problems, and then people be like, I didn't see any of that. So we'll hope everything. My Pearson should work. Sounds perfect. Volume is loud and clear. Awesome. Good to see you, Sarah. Good to see you, Dylan. So if you have questions, feel free to ask. A few people are emailing me questions. I'm going to try to get on here as much as I can to do problems, but ask your questions that you have. We will start working some problems. Who's working on a homework problem that they have questions on? And we can pull it up right here. Any sort of homework problem you're thinking about. And we should have the green screen going maybe next week. So fingers crossed, start looking more professional in here. Maybe I'll figure out a way to make it a standing desk. Can you do problem 5 on the homework? You bet. Amber, let's make you a mod too. Good to see you here, Amber. So let's go here, add moderator. You're now a moderator. And so let me go into our course and get number 5. Do you remember how number 5 starts? Well, I can find it because the quizzes are randomized, but for quizzes, I always have to know what the problem is. What is number 5? And this is on chapter 14 or 15, Amber. Chapter 14 or 15. We can do as many problems as people want. And this is kind of my new office hours where I'm like helping you out. So, and I really appreciate everyone being here. I know it's like crazy of times, but it's the numbers actually, the peak went, the peak went it went down a little bit today. The new case peak went, this was like today. So it's like, yay, and that's the number of new cases, like worldwide. So that was today. It's never, I think it's done like this before, but today it actually did that. Now it's still more than usual, and people in the future are probably like, what is he talking about? Don't worry, future people, it's all good. It's about how researchers measure, oh yeah, that one right there. Yeah, that's, okay, sampling distribution, sample proportion, sample mean, excuse me. Sampling distribution, sample mean, let's do that one right there on the homework. This one, when you see how it works, you'll be like, no way. You'll be like, really? That's how it works? It's got a trick to it. Okay. So we should have the homework appearing here. Hopefully my Pearson is working tonight really well. Oh, come on, my Pearson. You can do this. You did it, my Pearson. You achieved it. You got into the quiz, the homework. Okay. So this one looks like quite the crazy problem, but there's a key concept for this one. As long as everything loads up, there's a key concept that we should know for this. We should know that the mean for the distribution of the sample mean is equal to the mean. And the standard deviation, can we move those down? Good. The standard deviation for the distribution of the sample mean is equal to the original standard deviation over the square root of n. So listen key to those words again as I highlight them. The mean, which is the expected value for the distribution of the sample mean, is equal to the true mean, the population mean. The standard deviation, which is variation for the distribution of the sample mean, is equal to the original standard deviation divided by the square root of n. So as standard deviation gets larger, as sample size gets larger, standard deviation gets smaller. So we're going to grab the problem right here and we're going to take a look at it because there's a bunch of theoretical stuff in this. So we always grab our problem. So we can bring it over to the Word document and start highlighting stuff. Perfect screenshot. I'm always hungry. I just got hungry for cheddars. We were talking about cheddars yesterday on stream. And so, I don't know, everyone's like, now why'd you make me think of cheddars, Brian? All I can think about is those croissants. One of these days someone's going to sponsor us. It'll be cheddars. Okay, so here we are. We got the waist size of 952 men. So this is the total population. Now here's the tricky thing. This is actually capital N, not little n. So that's the full population right there. And then we're going to do sample sizes from that. So everything over there is actually n as it's being told to you there. We don't talk about population size much. It's just we don't use it in calculations because statistics is about samples. So whenever you're doing statistics, you're coming up with a sample size. So we don't really talk about population much because we want to understand the population with statistics. So we get right here that we know the mean of the population is this. So let's put a little space pen going out from this. The mean of the population is this, so that makes that mu. And then we've got the standard deviation of the population is this. If you notice how I mentioned that these are for the population? These are not for samples. These are the truths. So does that make sense right there, Amber, that this is for all 952 men, which is the population. So the population mean is 36.29. The population standard deviation is 3.97. So those are both mu and sigma right there in these formulas. So that, yes, cool. Notation, notation, notation. We always try to memorize our notation. That's always what we should have up here. Now, what's interesting is each of these are actually y bars. These are all y bars. I only put 3 of them, but it's too big. My handwriting's too sloppy. And these are all SDYs. Let's put SDYs right here. I guess they're more just standard deviations because they're not the SDY bar. I want to clarify because we're about to solve this. They're more just standard deviations. They're more just S's because they're standard deviations from samples. So they're not SDY bar, and the other one is not actually mu y bar. It's just a y bar, and the other one's just an S. It's just a standard deviation. So what is this problem getting at and what's going on? This problem is a theory problem. It's a theoretical problem. So tell me this. If the mean for guy's waist is 36.29, you took a sample, what mean would you expect to see? If the mean for guy's waist is 36.29, what mean would you expect to see in a sample? If the mean for guy's waist is 36.29, what would you expect to see in a sample? And remember, this is the first formula we just did a moment ago, right here. It's this one that I'm hovering over right here. If the mean for guy's waist is 36.29, what would you expect to see in a sample? And if you notice, this is a very simple formula. The answer is, anyone know in chat? Who knows? 100,000 points, who knows? If the mean is 36.29, then what would you expect the mean in a sample to be? Remember what was here just a second ago. So what is the answer for what we'd put right here? What would be the expected mean for the distribution of proportion? Chapter 14 is chapter 14 quiz part of exam 2. Nope, this won't be on exam 2. This will not be on exam 2. And do remember that your quiz average is averaged into test 2, and it can only help you. So do the quizzes. I beg of people, do the quizzes. Some people have made there's been some great grades on exam 2. Some people have made in the 90s, and it can only help you. So Andrew, to the rescue. Nice job, Andrew. So you are right. If the mean is 36.92, then all we have to do is do this, and there's all the means. That's what we always expect the mean to be. The sample size won't change it. Remember what the formula is just a moment ago, that the formula is simply just this right here. So it doesn't matter what the sample size is, it'll always be 36.29. We expect this to be the mean regardless of the sample size. Now the standard deviation will change, so we have to go to the standard deviation right here and put 3.97. Now each time we do this, what changes about it? The sample size, to where it'll change from being 2, then it'll change to, why didn't that control Z? There we go. 5 to 10 to 20. So each time we do this, who wants Andrew's 100,000 points? First person to say me gets them. So this is the, we do 2, then 5, then 10, then 20. So this changes the standard deviation. What's going to happen as it goes up? It's going to get smaller. Now, if you notice, this is a simulation over here, and we don't see the same numbers because these are actual sample means, and these are standard deviations right here. So we don't see this in the simulation. It's just kind of like, here's a simulation, and then here's what the theoretical answer should be. So we have to go and take our calculator now and do the theoretical for the next part. Here's the next part about standard deviations. So the standard deviation will be square root of 2. This is 3.97 divided by square root of 2, and 2.807, so 2.81. If I could type. No one's taking your points, Andrew. Oh, no. They're listening in so intently. And then square root of 5, so 5 square root. And then we take 3.97 divided by this. We get that, 1.78. And then we go here, and we take 10 square root, and Peyton's got it. Peyton's got the points. So we go, such a jokester, Andrew. And then we go right here, 1.26. And then we go right here, and we take 20 and square root 20 and do 3.97 divided by this. And that's 0.89. Now, if you notice, the answers are all kind of close to the ones over here. They're not exactly, nice job, Andrew. They're not exactly those, but they're pretty close, and we got them right. So, whoops. Oh, no. Come on, my Pearson. My Pearson, no. No, is anyone else having my Pearson troubles? Not again tonight. I bet everyone extended their homework assignments to tonight also. It's been working all today pretty well. I haven't heard problems, but the problem is everyone's probably... Oh, are you having my Pearson problems? Is that a yes? You're currently having my Pearson problems? Oh my gosh. I'm so sorry, everybody. We're just trying to, my Pearson... I know. Well, tell me another one. I can do other problems. Oh, it did it. It worked. Woo! We got it. We're going to keep doing it right here. We're just going to keep trying through. We got this. These values are very close, so the simulation and theoretical values are very close. It's working. It's working. We got this. This one is always the question I hate. Just keep trying to reload it. We're going to cross our fingers. That's what we gave till Tuesdays because we're like, just don't... the exam is a little tough, but here's the biggest thing. Do the quizzes. Like, that's the biggest thing I've been trying to... like, some people, don't worry, if I've been responding to a lot of emails today, like 100 or so. And a lot of people have been worried about their exam grade, but there's a lot of good grades. There's a lot of people in the 90s and the 80s. There's some 70s, there's some 60s, some lower than that. But we're going to look at the average and make sure it's comparable. We want it to be a little higher than exam 2, like normally is, but we're going to be, and it only goes to chapter 13. You can only access chapter 13. Yes, so that's the only one that we have open. We have chapter 13 quizzes open right now, and I can do one of those problems if you want, Sarah. If you're like, hey, do this problem, I'll work that problem and explain those topics. So this is new material. You got, Andrew, you're so positive. You're so awesome. I think, this will give away the answer. I think it's 10. This is like my least favorite question. Oh yeah, let's do that one here, Jackson. We'll do that one next. Is it 10? It's gonna be 5, really? 5, really? There we go. Memorize that one right there. That's a little bit of an unfair question because they're saying at 5 it's normal enough, and then 10, I hadn't worked this problem in a while. There's like always one I kind of dislike a little bit. Luckily, this is a homework one. That's why we sometimes pick one like this, because if you get it wrong, you get another try. It's definitely 5 or 10. It's just that it's not really that skewed, and it's like tiny, tiny skewed. So you have to look at the histograms, and it's definitely not normal here. And then it's normal here. It was really between 5 and 10. And I was like, okay, that's more normal. That's more very normal. That's pretty much normal. It's like very normal, pretty much normal, and my Pearson wants this to be the answer. So definitely seeing the answer in the video, but that's what it's getting at. At 20, it's super normal, and at 2, it's still skewed. So that's not a large enough N. So chapter 13, which one are you struggling on, Jackson? I think you might have emailed me. Is there a specific one? Are we allowed to use, no, not your own calculator on the exam. Make sure you're using the calculator on the site. It'll have a button up there. It'll have like a scientific calculator button at the top, so make sure to use that, Summer. Good question, Summer. And I think Canvas is like not sending my announcements because I put announcements up, and I think due to maybe instructors sending out so many announcements, I think like my announcements are not going out because I got an announcement from like earlier today that I sent, and I was like, I don't know if many people saw my live at 7 announcement, but I didn't get that one. And I was like, what's going on? Scratch paper, yes. Scratch paper, yes. Good job, Kyle. Ask all the questions you got. That's why I'm here live. So subscribe to the channel if you want. And whenever I'm live, be like, hey, Brian's live. I can ask him any question, and I'll get an answer like that. That's why I really like this platform right here. It's very easy to see when I'm live on YouTube. You can come in. Oh, thank you, Andrew. We want to be really positive with you guys. We want you to know that we're here to help you. We're going to, let's say the average on the test is like a 60, which I doubt it will be, we'd be curving it. So the average on this test is usually about a 75. If it's 76, 77, it's probably going to stay. If it's like 70, 68, we're probably going to curve it. So just know that we're going to look at all the grades. So when you get your grade, compute what it is by averaging your quiz score into it, and that'll tell you what you have. Make sure that's what finally appears in the grade book. And if after the averaging, the average is something like like an 81 or something like that, we won't be curving on, not probably, but if the average is an 81 after we do the averaging with the quiz scores, and we did this because we understand a lot of people studied really hard the week before the exam. We're so sorry. You guys probably know with all the closings right now, I was the one who said, no exam. And I know I called it like the day of, but I think it was the day that they were saying, I don't know if we had our first case in Knoxville that day, but there was hype over it and everyone was on edge. And I was just like, we got to cancel this. I had people being like, yes. I had people being like, no. And I was like, no, we got it. And I know it was very close to the time, but everything was just boiling over. So I still stand by what I did, and I appreciate everyone who's given me a lot of good vibes from it. So that's the question. Let's do it. It is believed that as many as 12% of adults have never graduated from high school. We wish to see if this percentage is the same for the 25 to 30 age group. And is this a quiz problem? Okay, let's do it. This is chapter 13, and this is sampling distributions quiz. Okay, let me pull this one up. Good to see you, Julio. So let's do this. Oh no, come on. Please tell me my Pearson's not down right now. Julio, we should do an interview again. We should, if you're hearing this right now. We don't have to do an interview now, but we should do an interview and have some fun talking about baseball. Maybe the students would like that. I don't know if you'd want to. It's down for me. Yeah, it looks to be down for me. I think I know the Jackson. I'm going to work that problem. My Pearson, I'm sure they're being bombarded by every student doing their assignments, and maybe like a bunch of classes like bought my Pearson because like they're like, well, we can't do assignments anymore, so let's buy my Pearson. So it's really tough. I'm not mad at them. I just know it's a tough time. If the internet, just inform us. If something crazy happens, please just tell us. We'll be very understanding. It'll show like in the video, like internet disconnected. So just tell us and we will like email us immediately, like from your phone. Yeah, Andrew was in the class last semester. He was so psyched from that. I've got it cut up. I could upload it. I literally have it cut up and ready to upload. And I was waiting for like an opportune time, like during like finals week for something fun. Yeah, Julio, if you're up for that, we could do that. And like, I don't know if you know, anyone, like it's like fun. I love it. It's like if you're whatever, oh man, I love the camaraderie in the chat. I'm going to keep trying to get my Pearson to work. Jackson, let me just do the problem from memory. I think I know this one. Okay. So Jackson, I think I can do the problem. You can tell me if it looks like it. Did you also, if you send me a picture of it, let me look at my Gmail real quick and see if you sent me a picture of it. Yeah, I know. People are, there's emails about my Pearson. My Pearson, start working. Let's see, Jackson, did you, here it is. Jackson, you are a hero because you sent me a picture of it. And now from your picture, we will work the problem right here. So Jackson, amazing work. Let's all thank Jackson. Like literally, because now we can work another problem literally the way my Pearson intended it if it was working. Okay, so there is the problem. Thank you again, Jackson, for sending it. It's so awesome. Okay, it is believed that, and thank you everyone who takes really nice screenshots. It's so easy to read this right here. It is believed that 20% of adults never over 50 never graduate from high school. We wish to see if this percentage is the same among 25 to 30-year-old age groups. Allow us to increase our confidence interval 95% while reducing the margin of error of 2%. Okay, so let's start marking down what we have in this problem. What we have right here, this is going to be the ME. That is the margin of error. So I'm just bored at home. So oh, man. Wait. Julio, you're so quick that you like, wow, you're getting better at this than me. So we should have guest teacher Julio. That's what we should do. I'm not joking. That'd be really fun. Like Julio, you guest teach the class. I'd like that. So this is going to tell us the Z-score, which is going to be 1.96 because it's a 95% confidence interval. And there we go right there. 50 is going, that's not sample size. I'm tricking myself right there. This is a weird problem because this one, you have p hat right here. And so we've now identified all the notation in our problem. So a lot of the keys to these problems is going through the start of it and making sure you get every bit of notation. So we've got all the notation here that we want. And now let's start doing it. The only thing we're solving for is the margin of error, or we're solving for a sample size to get a margin of error of 2%. So the margin of error for this interval is Z, and it's a little too low right there. So it's 1.96 right there. That's what the Z is. Z is 1.96. And this is p hat. over n square root. So this is the margin of error right here. And Andrew, if you have any questions, feel free to ask, especially towards the end. If we don't have many questions, we could do some 320 if you want. So, 'cause I don't know, I'm bored too. So we have here, well, I mean, I'm answering emails and everything, but there's not much else to do. And no one, yeah. So let's do this right here. We got the margin of error of 0.02, and that is equal to 1.96 times, and good, that's not covering me up, and then 0.2 times 0.8 over, and then we need to solve for n. So this is where it becomes an algebra problem now. Is this making sense, Jackson? Is everything I'm doing here making sense? Be back here in 2 seconds. I'm going to take a quick break after this question. Why do we put the ME there? Because this is the part of the formula. This is just the margin of error part of the formula, the p hat plus or minus z star p hat q hat over n. So this is the only part of the formula right here that we're dealing with. So we're just dealing with the margin of error part. It's everything after the plus or minus. Does that make sense? It's everything after the plus or minus. And I'm going to take a quick 4-minute break after this question real quick, and then I'll be right back. So to solve this right here, we just have to algebra this part of it. And so we're going to take and divide this by this right here. And then we're going to square it. And then, so this is equal to 0.2 times 0.8 over n. And then we do the cross multiply thing. And the cross multiply thing is going to give us n over here equals 0.2 times 0.8 over this right here. And I will be right back here in just a moment. So give me a moment. I'll be right back. Rewind the video if you missed it. Here, I'll be right back. I'm going to put the intro screen back up, but I'll be right back in 5 minutes. So give me... Hey, I'm back. So I saw Julio, you were commenting on, you thought the margin error was the critical value. I saw the comment here as I was, there you go. The critical value right here is Z times P times Q over N squared. And for the confidence interval, it's going to be P hat times Q hat. So this is the margin of error for a confidence interval. Does that make sense? And I saw Sani is here. Sorry, Sani, that we were on pause for just a moment there. Does this all make sense right there? Did I lose everybody? Hopefully I didn't lose everyone. 10 people still watching. We're good. So we still got people watching. And what other questions are there? We'll see if we can get another My Pearson question up. All good. Sonny, do you have a question on any of the homework problems? And let's hope My Pearson is working. Ask any question you have, test related or any question. People might be jumping in to say hey and asking questions. My Pearson might be down again. Oh, no. Yeah, it looks like My Pearson's not working again. So if you have a question, feel free to ask. I know. It's so crazy. We might be pushing back chapter 14 on the test. Is it multiple choice? It's pretty much multiple choice, true, false, and some where you have to put in numeric response. I streamed also earlier, so I did some here. Sonny, I'm gonna make you a mod right here. Peyton, we're gonna make Peyton a mod too. I did some streaming earlier, and so I did some questions there, but does anyone have any question they are thinking of? Like, if you remember any part of the question, I pretty much know all of them. And my Pearson literally crashed as we started streaming. It's like, Julio, I should like call you up. We should do an area mod stash. You're welcome there. And I think Andrew, I might try to do Twitch tomorrow, like after class. What I'm hoping is, and who has a question on anything, be like sampling. You could say sampling, decision trees. We did decision trees yesterday also. Sampling, decision trees, probability, confidence intervals, or sampling distribution of sample proportion. So I'm just going to kind of go off on what's on the test right here. So on the test, it starts with randomness, decision trees. Finally learned how to spell that. Probability, sampling methods, sampling distribution of the sample and confidence intervals. The true proportion. So these are the topics. There's not a proportion. These are all the topics on the test. Yeah. So does anyone have any questions on these or any of the homeworks related to these? There was a problem with My Pearson. You don't say. So it's ay. It seems like it might just go down like every night from now on. The problem you take 0, 7 through 9. Oh yeah, is that the practice test problem? You take 0 and try to get 10. Is that the randomness problem? It's I think you're talking about is it the multiple choice problem where you have to do the multiple choice and you're trying to see that yeah. Which chapter is it in? Take 0 and 7 through 9. Oh, the dice roll one. Yeah, the dice roll one is a really good. Okay, yeah, that's it. It's the sorry dice roll game one. That one is a really good random number question where just literally you take random numbers like this. You can't put a dash, and these all become dice rolls. So this is kind of random numbers right here, and then we have to think what would be on a dice when we do dice rolls. No. Yeah, right back. So how can you tell us if the sampling distribution is skewed? 2 seconds right here. Checking out something real quick. This question right here. We'll do this problem and then we'll do the next one. So with this one right here, we have to understand for dice rolls that dice rolls are going to be only numbers 1 through 6. So we need to go in here and start removing the numbers that are not 1 through 6. So let's go here and use replace. We're going to go to 0 and replace all the zeros with nothing. And there were very few zeros. Then we're going to replace all the 7s with nothing. Then we're going to replace all the 8s with nothing. And all the 9s with nothing. We can see how random I made this. You can see my pattern is not too good. And so now we can play the game. So the biggest thing I support when you do a randomness problem is that every randomness problem you need to understand the rules. And the rules for the dice roll problem, so if anyone's working right now, is rule number 1, you have to move 10 spaces to get home. And you're trying to play a trial right here. Rule number 2, you cannot go over 10. I think a lot of people don't realize that when we do this game right here, we'll play the first round of it, and maybe we'll just complete it. Cannot is a word like that. You play it right here, and you go 2, 5, 9, and then this is over. We can't use that roll, and that's all the rolls I took to get home. So we actually have the same pattern here. Wow, this pattern... I don't think my pattern was very random. That was 2, 5, 9, 10. Then here we have 2, 6, 7, and then we get to 9, and then we can't use these. We have to go here. Then we go 2, 5, 9, 10, because we can't use the 5. And then here we have 2, 6, 7, 9. Oh, we'll pretend that didn't... I can't do that. People are going to wonder why I did that. We'll put a 1 over here at the end, but this would be 5 simulations of dice rolls right here. Does that kind of make sense here, that this would be 5 simulations of dice rolls right here? So with the 5 simulations of dice rolls, we see what would happen if we were simulating this game and rolling dice. So we can see what happens right here with the simulation of 5 trials of dice rolls. So, and then how can you tell if the sampling distribution is skewed? And then, so Peyton asked that question. With the sampling distribution, which is a problem right here, the sampling distribution of the sample proportion is going to be, we will generally tell you with these problems, we'll generally tell you right away that it is either, let's put a little highlight around this, that the sampling distribution of the sample proportion we will state in the problem is either normal, skewed, or very skewed. We will state this in the problem, the shape of the sampling distribution of the sample proportion. 2 seconds. Be right back. Sorry, everyone. Be right back here in just 2 minutes real quick. Ask questions if you got them. I'll be right back. Hey, I'm back. There was a problem on chapter 13 about smartphones, I think, and it asked about if it was skewed to the left or skewed to the right or unimodal. So let's see right here. I'm trying to get my Pearson to load. You might have to email me that question, and I might have a video on it. I'll try to find if I have a video on it. Of course, my Pearson is down. I'm so sorry. If it's skewed, do we do all the work with the... And so, well, there's a few different things in there. So when we talk about the distribution being skewed, we'd be talking about the next chapter. So uh, I think, Peyton, I think the smartphone one is going to have that it's going to be unimodal because this is going to be, and I went too quick. I was like, wait a minute, it's the next chapter here. The sampling distribution of the sample mean is the next test. Next test. Sampling distribution of sample mean. That would be the next test. So I'll be right back, everyone.